Okay, last time we saw how to convert numbers into this modulus argument form. If we have the modulus argument form and we want the Cartesian form, how could we do that? Well, let's just have a little sketch of where this is. So 3/4 of pi radians is over there, so it's that way, and it's 3 out. So this is a length of 3 and an angle of 3/4 of pi. We can find its Cartesian form by thinking about some SOHCAHTOA, some trigonometry. Remember, a cast iron, this will be easy. So we know that the x direction in our Cartesian plane is linked to cosine. So in this case, it's our real direction is linked to cosine. So this real length here is 3 cosine 3/4 of pi. And we remember from our cast diagram that the sine will give us our vertical height because it's opposite the angle. So that means that this here is 3 sine 3/4 of pi. Okay? Now, 3/4 of pi might seem like a funny angle. If that is the case, that means you've forgotten about radians, which is what we're measuring in which case it's actually quite a neat angle. So remember, the unit of angle measure is going to be radians from now on, not degrees. It's 135 degrees if you're still a fan of degrees. So, this direction is imaginary, so we normally multiply this by I as well. We'd actually usually write it 3I sine 3/4 rather than I3. So, common factor of 3 here means I can write this as 3 lots of the real part, cosine 3/4 of pi, plus I lots of sine 3/4 of pi. And that's actually a general form. Okay? That's a general form of a complex number. We use quite a lot because it gives us like our real part quite clearly, our imaginary part quite clearly, and it keeps the modulus and the argument all in one place, which is very, very useful. So to summarise that in one place, z can be written as a plus bi, or it can be written as the radius, the modulus, and the angle, so with a radius and an angle, or it could be written as this trigonometric form, which is really a Cartesian form, which is r lots of cos theta plus I sine theta. And in this case, we can switch between whichever one we find more useful. If all I care about is the distance and angle, I can do that. If all I care about is the horizontal vertical displacement, I can use that. And if I need to translate easily, this has got both kind of locked up in it. But it is longer, so it has got a downside. And we'll come to look at how these all link together and use in their calculations later. At the moment, we've only been working with this type. But now we've got a geometrical interpretation, we can start to think about how these interact. Enjoy.